All right, everybody, let's talk about standard form of a linear equation. So there are three forms of a linear equation that you'll need to know. Slope-intercept, y equals mx plus b, where m is the slope, b is the y-intercept. Point-slope, which is y minus y sub 1 equals m times x minus x sub 1, where m is the slope, and x sub 1 and y sub 1 are any point on the line, doesn't have to be a y-intercept. And then standard, which is kind of a weird form because it doesn't have any direct application to the information that you're given. Like point slope is like, hey, slope point. Slope intercept, hey, slope y-intercept. But the standard form is just, it's got this A, B, and C, and there's no direct correlation. I mean, there is, but not directly from the information. So whenever you're trying to find standard form, the way you're going to approach that is get either a slope-intercept form or point-slope form and then algebraically manipulate the equation to turn it into standard. You never want to try to go straight to standard. So these two forms are going to be your workhorse forms. They're going to be the ones you always start with in order to get it into standard form. So to see how this works, let's go through 56 through 59. So a line is determined by a point and a slope. Point gives it its spot in the xy plane, tells you where it's going to go. The slope tells you the tilt, and that's enough to determine a unique line. So on 56, we're given that it passes through 1, -2, and has a slope of -5. So we could choose slope-intercept form, or we could choose point-slope form. Either one of these would be fine. But point-slope looks easier because we're given a point that's not a y-intercept, and we're given a slope. So I'm going to start with that. Y minus the y value of the point I'm given equals the slope times the x value of the point I'm given. And of course, that would be y plus 2, -5, x minus 1. Now, if I were asked to write the equation on the line, and I said get it in point-slope form, I would be done. But I was asked to get this in standard form. So in standard form, I need to have the x and the y on the same side, and any constant terms, things with no variables, on the other side, and I can't have any fractions. So to go from point-slope form into standard form, I'm going to start by distributing that -5 like that. And then I'm going to move the x and the y terms to the same side by adding the 5x. And then I need to move any constant terms, terms that don't have any variables in them, to the other side. And that is in standard form. I don't have any fractions, so I'm good to go. Now, some Algebra 1 teachers really harp on the fact that the x term, the a, can't be negative. That's not a big deal to me. So let's talk about 57. Passes through 1, -4. And the slope is undefined. Now, undefined slope is a challenging thing to write an equation for, because if you have a slope that's undefined, you don't have a number for it, right? So you can't just drop it into slope-intercept or point-slope form. The thing you need to know if the slope is undefined is that that means the line is vertical. Because if you think about slope being rise over run, the line doesn't run at all, so you'd be dividing by 0. Now, when you have a vertical line, and I were to pick 2 points on that vertical line, their x values would be the same, right? So whenever you have a vertical line or an undefined slope, anytime you have that, instead of trying to write the equation and convert it, you're going to basically say the x values on that line are the same. So x is going to always equal the same number. And then you can look at the point that you're given, say the x value here is 1, so my x values are always going to equal 1. Now, some teachers would say that's not really standard form because it's not ax plus by equals c. So we can make it that way by saying we have an x, there aren't any y's, and that equals 1. For my part, I would be okay with just saying x equals 1. Now, 58. We have that it passes through -1, -1. So there's a point, and we know that it's perpendicular to this line. Now perpendicular and parallel. Parallel, which has this symbol, means same slope. So you'd have to find the equation of this line, find the slope of this line, and then you use the same slope. Perpendicular, you change the sign and flip the fraction. And we call that an opposite reciprocal. So the slope of the line I'm given is 1/2. If it's going to be perpendicular to that, I have to change the sign, so it'd be negative, and flip the fraction. So the slope would be -2/1, which is -2, of course. So now I've got a point in the slope. I could drop it into point slope, or I could work to get it into slope intercept. It's all depending on how you want to do it. I'm going to go ahead and put it in, and let's do slope intercept this time, just so you can see how that works. So if I wanted to go directly into slope intercept form, I know the slope is -2, but I don't know the y-intercept here because I wasn't given that. I do, however, know a point that passes through, -1, -1. So if I stick that point in for the x and the y, that allows me to solve for the y-intercept. And then that means that when I find the equation of this line in slope-intercept form, I can write it like that. Now, it was still, we were asked to get it in standard form, so the x and the y had to be on the same side. So I'm going to add 2x to both sides. Constant terms all have to be on the other side. It's already that way. And no fractions, and there aren't any. So now let's just look at 59 real quick. Now 59, we're given 2 points. So we have a choice of 2 points. We can use either one of those as our point, but we don't have the slope. So we're going to need to find the slope first. So my slope, which is n, is the change in y. Now you can do either the first point first or the second point first, as long as you're consistent on top and bottom. I'm going to put the second point first. 3 minus -2 over 5 minus 1. That's 5/4. And now I'm going to use the slope-intercept thing I just did before, just so you can see it again. So y equals 5/4 x plus b. I'm going to choose one of my 2 points. Let's say I choose this first one. It does not matter which one I choose. And I'm going to plug those in for x and y. I'm going to solve that for b. So let's see, -2 minus 5/4 would be -8/4 minus 5/4. So that's -13/4 is my y-intercept. That means my equation is 5/4 x minus 13/4. And I want to get that into standard form. So I want to get the x and the y terms on the same side. I want to make sure I have the constant terms on the other side. That's already true. And I don't want to have any fractions. So this one has fractions in it. It's got the 5/4 and the 4th. The third -13/4. So to get rid of that, because this is an equation, we're going to multiply both sides of the equation by the denominator of the fraction. Now, if we had different denominators, we would multiply both sides by the common denominator. But since the denominators are all the same, we can just multiply both sides by 4. 4 times 5/4 x would be 24 x, which is 5x. 4 times y would be 4y. And then 4 times -13/4 would be -13. And that's standard form for number 59. So the idea again behind standard form is this. You start with a different form unless you have an undefined slope. And that form can be either slope-intercept or point slope. You algebraically manipulate that equation until the x and the y terms are on the same side, the constant terms on the other side, and there are no fractions.